Okay, we're moving on to the next theorem of 2.2, and we introduced this already in my first video with points of inflection. And so we had this idea of this points of inflection here. There's a definition of that. If f has a point of inflection, it must occur at point 0, or using our theorem, in the domain of f where f double prime equals 0 or f double prime doesn't exist. So we find a place where f double prime equals 0. It may have a point of inflection. Again, if f has a point of inflection, it must occur at this value, right? Where f double prime equals 0. And a point of inflection, again, is where it changes concavity, which we talked about in the introduction video. And a point of inflection, well, we'll look at an example. Let me just remind you what we looked at in a point of inflection. Let's see if I can pull this up accurately. That's your notes there, concavity. Points of inflection. Points of inflection, if you looked at this introductory, again, is where it changed from concave down to concave up. Right, so in this purple here, it's concave down, concave up, and then this point here is the point of inflection. And so kind of taking a look at that, it's important to kind of recognize that point. But again, review that video that we had. So let's go ahead and again look at how do we go about this. For quick check 2, what would we do for that, right? And so on quick check 2, you have that function. So this is the same function that we had earlier. We found all the critical points. And now we want to find the points of inflection. Points of inflection are going to occur when the second derivative equals 0. So now what we're going to do is you take that second derivative. Where's that second derivative at? Here. So we need to check here. So to find the point of inflection, we need to find where g double prime is equal to 0, and then show that there's a change of sign, meaning that it went from a negative to a positive, meaning it went from concave up to concave down. And that's what we mean here when we say change of the sign of the second derivative. We're really looking to see if it changes concavity. And so this language right here, let's do it in a pen, this language right here, a change in the sign of g of x, really what we're saying here, right there, is what we're talking about is a change of concavity, okay? Which means if you have a change in concavity, you have a point of inflection. That's the idea what we're talking about here, point of inflection. And so on this problem here, you can see we have this derivative. The second derivative is the derivative of the first. So we're taking the derivative, and so here is the second derivative right there. So it's kind of hard to see so with all the writing there, but what we end up pulling out here is the second derivative, f double prime of x, is equal to 60x 1 minus 2x squared. So you have that there again. And we calculated that earlier already in the previous quick check. Where was that at? When we did the second derivative, right there. Okay. And then we just then went ahead and factored it out right here. And so now what you do is you set each of those pieces equal to 0. And what you do is then you found new critical values. This one here gives you these weird numbers square root of 2 over 2, and again that comes from 1 minus 2x squared equals 0. So in this case you have 1 equals 2x squared, and then divide both sides by 2, so you get x squared equals 1/2, and then that leads you to x is equal to square root of 2 over 2. Again, as you take the square root of both sides, and then that turns into that when you simplify it, okay? And so now these here, we can solve for both, which we've done. 0, 0, again, comes from when you plug 0 into the function. Plug this into the function, you get this point. Plug this into the function, you get this point. And then those are what we call our points of inflection. And so that's where we would grab that. And so if we go back to the original graph, if we look carefully here, you would see We have points of inflection here, and then we have another point of inflection. It's down and up right here, and then you have this other point. So it was down and then up, and then it goes down and up. So right here you see your 3 points of inflection. This comes back to the graph from Quick Check 1. So we have the points of inflection here. I'll put it in green. Points of inflection in green, and then that's different than what we call our max and min points, right, with the first derivative test. So this is a min. Here was a max. But the ones in green, the points in green are points of inflection. Okay, points of inflection here, and that's where the concavity changes. And so again, you can kind of see here, it holds water, so it's concave up. From here to here, you have concavity down, and then from here to here is up. It holds water. From here to here, it's concave down here. And so that's why we have these points of inflection as it's stated in here. So you can take a look at the original graph, and then you go ahead and then look at how we got these solutions. Again, those come from plugging in. Once we found where the second derivative equals a 0, which are 0, square root of 2 over 2, and negative square root of 2 over 2, which here, remember, this is a plus or minus, and you substitute those in to the function, right? F of 0 equals 0, f of square root of 2 over 2, f of negative square root of 2 over 2, and then you get 2.475, and this is negative 2.475. Again, those values are our points of inflection.